In this session, we are going to discuss what are the factors affecting the detonation. Okay, so now see, the factors are intake pressure, intake temperature, maybe compression ratio, air fuel ratio, engine speed, engine load, turbulence. Okay, so now that way, see here, what are the factors affecting the detonation? If the intake pressure is high, then detonation increases. So there will be more detonation. Okay. Inside the pressure is high, then there will be turbulence. Okay. So many fuel will be mixing inside the combustion chamber and detonation effect will be too much there. Also detonation increases. Similar way, if the pressure increases, intake temperature also increases. That is, once again detonation is high here. That means we can call it that if the intake temperature is increases, then definitely detonation will also be high in that case. Okay. Another is compression ratio. See, intake temperature, intake pressure and compression ratio. All these three are interrelated. So intake temperature and pressure will increase the detonation, then definitely compression ratio will also increase. It will also increase the detonation. Okay. So that is the increasing the detonation if the compression ratio is high. Air fuel ratio, if you increase, that is near about 10% of air fuel ratio, then detonation will reduce. Detonation reduces in that case. Okay. So air fuel ratio is 10% of the mixture. So in that case, detonation will reduce. Then engine speed. If the engine speed is high, so detonation reduces. So there will be less detonation if the engine speed is more. What about engine load? If the load increases, so there will be, if the engine load increases, so detonation is more or detonation increases. Okay. So now turbulence. If the turbulence is very high, definitely detonation is less. Okay. Remember, these are the factors which will promote ignition lag also. Okay. So intake temperature, intake pressure, compression ratio, the 10% of air fuel ratio, engine speed, engine load, turbulence, these are the factors affecting ignition lag, flame propagation, and due to flame propagation detonation will occur. Okay. So remember, this is the just opposite of ignition lag actually. So if the intake pressure increases, their ignition lag decreases. Okay. So just this is detonation is just opposite of ignition lag. Okay. So properties which promote ignition lag, will reduce, promote this point which will promote ignition lag will reduce the detonation. Okay. So that is the principle. The property, suppose for example, compression ratio, if we will increase the compression ratio, then ignition lag will be less actually. Okay. So if we increase the compression ratio, then ignition lag will be less there. But remember, that will increase the detonation. That's why I have written here just opposite of ignition lag. So properties which promote ignition lag will definitely reduce the effect of detonation in SI engine. Okay. So that point we have to remember. that is variables, factors promote ignition lag will reduce the detonation. This point you have to remember and keep it in mind. That's why I have written just opposite of ignition lag. So intake pressure increases, detonation increases. Intake temperature increases, detonation is high. That is also increases. Compression ratio increases. That means increase the detonation also. Okay. Air fuel ratio 10% of air fuel ratio. That detonation reduces. Air fuel ratio 10%. So reduces. Engine speed. It will also reduce engine speed. Detonation reduces. Engine load. Detonation is more. Turbulence. If the turbulence is very high, then definitely detonation is less. Okay. So these are the points affecting your detonation. Okay. So rest of the thing I will discuss in next class. Thank you.